Hello and welcome to fourth grade's Math Dive in 5, focused on understanding angles. Today we are going to focus on part 1 of a 3-part session in regards to identifying and classifying angles. My name is Emily DeVizio and my partner today is
Joe Ratasky. So before watching the video, you have a task to do if you wish. Pause the video here. You can scan the QR code or enter that shortened website link there, and you will get a task about measuring angles. Before you do the task, there's 3 questions for you to consider. You can do this by yourself or ideally with your grade level team or a partner. And in order to receive your PD points, you'll want to visit our 4th grade Canvas course that's set up. You can answer the questions in there and complete proof of the task.
Make sure that you submit your answers individually so that you each receive points for taking this course.
Hope you enjoyed the task. Let's dig in. So first we're going to talk about classifying angles. We know our 4th graders need to classify angles as right, acute, or obtuse, and they also can look at straight angles and even reflex angles. But we want students to understand this conceptually, and this is without even that whole idea of measuring formally, so using those degrees. We don't even know what that means yet. A great place to start would be with square corners. In prior grades, students have had experience counting the number of angles or vertices in shapes, and possibly they even looked at the number of square corners. They may or may not know the term of a right angle. Informally, that might have been introduced, but they really didn't have to know that term yet until 4th grade. But students, in order to classify rectangles and squares, had to look for shapes that had 4 square corners in them. So one thing you can have students do is think of this idea of, can you look around the room and find some objects that have square corners? And how would you know that they're square corners? What could you do? What tool could you use? So a lot of kids are going to come up with just finding something in their room that already has square corners, like a Post-it note, a book, a piece of paper, something like that. So have kids look around, maybe give them some shapes, and practice identifying where they can find square corners.
Another great resource or tool to use are called concept cards. These are really great for students to be able to derive or generate their own definition or experience and explore with the different attributes of square corners in this example. It shows examples and non-examples, and then it provides students with the opportunity to draw some examples of square corners, as well as generate some characteristics that are common of square corners. In talking about square corners, if we want our students to compare the shape of a corner or the opening of one shape with another, how could they do that? One of the methods that our students can use is to overlap the 2 corners. So for example, you see here, this is a direct comparison where they're actually putting the figure on top of the other figure to compare the angles. Another method would be to trace around the angle arms that form a corner, recording those angles. So this is an indirect comparison. Here we can see some students may use angle legs, for example, or they may use a drawing, some kind of tool of some sort, as you can see examples here, to compare the square corners.
So this is kind of like when kids first started measuring lengths and they made their own rulers.
Absolutely.
Before being introduced to the ruler.
Teaching them the concept of what an angle is.
We can return now to the idea of classifying angles. So if students worked a lot with that square corner, we can now define that as a right angle. Using a square corner, it could be a color tile, a Post-it note, a book, a piece of paper, anything that they know has a right angle. We can now identify acute, obtuse, and straight angles. So I can take my color tile, put it right over this angle, and realize like, oh yes, this is exactly that square corner, so that's a right angle. Putting my color tile in this angle, I see the angle is smaller than the right angle. It's kind of hidden behind the right angle, so I know that that is an acute angle. The opposite, the angle extends past it, so we know that that's an obtuse angle. And seeing a straight line. I don't think kids explore straight lines enough, recognizing that those are actually a type of angle too.
I really think that spending that time focusing on square corners and then moving into it being a right angle and using that as a benchmark will definitely support students with classifying.
Yep, we even have these benchmarks in our measurement system, right? The biggest thing too you're going to get from this is that kids can estimate. So later on when they are measuring, if they make a mistake and use a protractor incorrectly, if first they've looked at, say, that second angle and said, I know it's acute, but then they look at the wrong number and get a measure over 90 degrees, they should then be able to be like, well, I thought I said this was an acute angle, so it can't be 120 degrees or whatever it is. Another experience you can provide with your students of looking at these different types of angles is working with pattern blocks. So taking the different pattern blocks, setting them on top of each other, maybe taking the green triangle and looking at the angle, finding if any of the other pattern blocks have the same angle as the green triangle, how many green triangle angles would fit on the angle in the yellow hexagon, things like that.
These models and strategies are included in the Unpacked PowerPoint within the unit, but here we could see, just as Joe talked about, in supporting classifying angles using the square angle or the square corner, and then later referencing it to be the right angle is something that you can use with your students, as well as the concept cards that I referenced earlier, focusing on examples and non-examples. As it says here, this helps students to identify and explain perhaps a geometric definition versus us telling them the definition and then making no connection to it.
Looked at angles and directly comparing them, such as taking a right angle and placing it on other angles to classify them. We want to also give students the experience of modeling their own angles. So this brings in another definition of the angle, really two, of that we're looking at the space between the arms of the angle and also thinking of an angle as a turn. Angle legs are a great tool. If you don't have that, you can just put two sticks together, glue them together. There's a lot of different materials that you could use. And fun fact, did you know that the word angle actually means a little bending? So it's kind of like a bend in a line, right?
Learn something new every day.
That's what we're here for. Since we are looking at the angle as a turn, a lot of students, especially in elementary, have that misconception that we're always looking at that smaller angle. But really, we could be looking at that reflex angle. We just don't explore it that much in elementary, but it's okay to talk about. In middle school, they're definitely going to look at that. And because we have both of those, that inside angle and that outside angle, that is why in math we've come up with using these little arrows to identify which of the angles we're looking at. Same thing's going to happen when we're looking at our polygons too, our shapes. There is that inside angle that's within the shape, but there is also an outside and exterior angle as well. So we want to make sure that we're defining which one we're measuring, which one we're looking for.
I think it's important to make that connection to the polygon so that students see that the angle is on the outside as well on the inside of the polygon. Just to reiterate again, these models and strategies are referenced in the Unpacked PowerPoints located in our instructional guides. The biggest component or the biggest takeaway from this is that we want our students modeling these angles concretely, very similar to when we use base 10 blocks, when we use fraction strips. We want them to identify and learn about the angles conceptually and then connect it to the real world. So here we can see, this is a brief summary of what we talked about today. As you notice, we have not even gotten into the land of abstract just yet. We are focused on concretely and representational of what an angle is and classifying angles.
I wonder what's going to be part of that abstract thinking with angles.
Stay tuned.
I guess you'll have to look at part 2 and part 3 to find out.
Thank you for joining us today. We hope that you got a lot of valuable information, and we will see you soon.